Now, with the continuation of this, now let's look at the same circuit, but now we will change some few components so that we can see how do we look at this in the next form of this. Remember, the one that we did, it was a Klemper circuit. Now, let's look at how do you look at this as a positive Klemper circuit. Now, as a positive Klemper circuit, you use the same source, same circuit, but, or sorry, same circuit component, but now the connection is going to be different. So which means you must be able to check how is the connection of your components? How is the connection of your component? Now, the resistor will stay as it is, which is 220 kilo ohm. Then your capacitor, now your capacitor is connected in this manner. You will see that the first one, it was positive, negative, but this one now is negative, positive. The first one, it was positive, negative. Now this one, it's negative, positive. Then here, you will see that now here, I have got this one is positive, that one, it's negative. Then I've got a diode. Now it's connected in this manner there. Now your diode is connected in this manner. Again, your diode, it is, okay, let's change the material of the diode. Now we are using a germanium diode. The germanium diode, that one is positive, that one is negative. Germanium diode, that one is positive, that one is negative. Now, if we are using a germanium diode, positive, negative, then let's see how your circuit will look like. Let's see how your circuit will look like. Now, if I look at this condition there, if I look at this condition here, with this condition, if my current is flowing in this direction, if my current is flowing in this direction, sorry, this is 220 microfarad. If my current is flowing in this direction, you will see that here it's positive, there it's negative, which means you're not going to be able to store charges on that component here. Remember, the characteristics of this component, which is a capacitor, it's two metal plates which are parallel to each other, of which magnetic field needs to build one on one plate so that it can be transferred to the other plate. Then you will have an induced EMF. Then you can store charges within this component here. But now, because it is connected in this manner, which means this component will remain at reverse bias. This component will remain at reverse bias. Now, we need to have a magnitude at which, when we look at the signal, we must look at the signal from which point of view? We look at the signal from this point of view, which means on the negative cycle. When we look at this from the negative cycle, which means here it must be negative, more negative, here it must be more positive, which means now your current is moving in that direction there. Now your current is moving in that direction there. Now, if your current is moving in this direction, now you are looking at this at minus 10 volts. That is the negative cycle, which means minus 10 volts with respect to the direction, direction of the current flow in this direction. Then this component this component must be able to go into forward bias, because positive is connected there, positive is connected there. Even though here it's on the negative cycle, positive is connected there, positive is connected there, which means it's going to force this current to go onto forward bias. If this component go onto forward bias, when is it going to go onto forward bias? It is going to go onto forward bias when it is what? When it is at minus 0.3 volts, because that is with the material which is used of germanium. With the material which is used of germanium, it says the voltage drop that can be established within this component is going to be 0.3 volts, which means your first voltage that you are going to measure, that is negative, positive, the first voltage that you're going to measure, which means now your V out is going to be V out of minus 0.3 volts. And if your V out is going to be minus 0.3 volts, which means this becomes your minimum turning point. That becomes your minimum turning point. Once I establish this minimum turning point, remember here, sorry, let me just complete this. Remember here, you have got your V reference. And in this case, your V reference is what? It's 0. In this case, your V reference, it is 0. Then you need to go and establish your new reference point, which means your new reference point needs to exist within that magnitude there, your V ref, which is your capacitor. Now we need to charge the capacitor. The moment you forward bias this component here, the moment you forward bias this component here, then also you're going to store charges within that component there, because you will have the continuous of current flow. But if you don't have a continuous of current flow there, which means you cannot store charges within that component there. Which means if I do the mathematical analysis of this, if I do the mathematical analysis of this, then you will see that now my V reference, or the V of the capacitor, your V of the capacitor, it is going to be what? It is going to be my 10, so your 10 volts minus 0.3, which means here is going to be your 9.7 volt. That is going to be your 9.7 volt. If this is your 9.7 volt, if this is your 9.7 volt as a new reference with the graphical representation, as a new reference with the graphical representation, which means now your graph, it is going to be what? It is going to be a minimum turning point of what? Of 0.3 volts, a minimum turning point here of 0.3 volts, which means it's minus 0.3 volts, which is your minimum turning point. With what reference? With the reference of 9.7 volts. With the reference of 9.7 volts, which means your graphical representation in this manner, it is going to turn there, which is your minimum turning point. Then what is your maximum? Your maximum now, it is going to be what? It is going to be this voltage and that voltage there, which is your 19.7 volts, which means if I establish this correctly, let's say that one is 19.37 volts, then it's going to turn at 19.3 there. Then this becomes your positive Glenn bar circuit. Positive Glenn bar circuit, which means for you to be able to establish this positive clamper, negative clamper, you need to look at how is your diode connected and how it is your capacitor connected. Once you establish these two, then you can know that it's either it is a positive clamper or it is a negative clamper circuit. Continuation of clamper circuit. We are done. Stop recording.